A signal from deep space, a planet that defies all expectations, and a race to another star. What if everything we thought we knew about the universe is about to be shattered? The James Webb Space Telescope, JWST, has uncovered secrets so shocking that they could rewrite the rules of life itself. But is Proxima b truly a new Earth or a deadly trap? In the vastness of space, the JWST, often hailed as humanity's most advanced instrument in the sky, has recently turned its gaze toward one of the most intriguing exoplanets ever discovered, Proxima b. This distant world, orbiting the red dwarf star Proxima Centauri, has captivated scientists and enthusiasts alike since its discovery. But now, with the unparalleled capabilities of the JWST, we are finally getting a closer look at this mysterious planet, and the revelations are nothing short of extraordinary. Proxima b was first detected in 2013, but it wasn't until the James Webb Space Telescope came into the picture that we could truly appreciate what lies on this distant world. The telescope's ability to capture infrared images has allowed astronomers to peer into Proxima b's atmosphere, revealing details that were previously hidden from view. What they found has sparked both excitement and concern. You see, Proxima b orbits its star at an incredibly close distance, just 7.3 million kilometers away, less than 5% of the distance between Earth and the Sun. This proximity means that the planet completes a full orbit in just 11.2 Earth days. But what makes this even more fascinating is that Proxima Centauri, the star it orbits, is a red dwarf. Unlike our Sun, which is a relatively stable star, red dwarfs are known for their volatile nature, often emitting powerful solar flares that can drastically affect the planets orbiting them. Now here's where things get even more interesting. The JWST has provided the clearest view yet of Proxima b, revealing startling features. For one, the planet is about 30% more massive than Earth, which means it has a stronger gravitational pull. But what's truly shocking is the possibility that Proxima b is tidally locked with its star. This means that one side of the planet is in perpetual daylight while the other is shrouded in eternal darkness. Imagine a world where the sun never sets on one side, while the other is plunged into an endless night. This tidal locking creates a harsh environment for any potential life forms. The side facing the star would be scorched by constant radiation, while the dark side would be a frozen wasteland. This raises a critical question. Could life ever survive in such extreme conditions? The possibility seems slim, but nature has a way of surprising us. The challenges don't stop there. Proxima Centauri itself poses a significant threat to the habitability of Proxima b. The JWST has revealed that the star is far more active than previously thought. Its powerful magnetic fields produce intense solar flares that bombard Proxima b with high-energy radiation. In fact, a flare observed in April 2021 was 100 times more powerful than any flare ever seen from our Sun. Such a massive burst of energy could strip away the planet's atmosphere, leaving it exposed to the harshness of space. Some researchers argue that Proxima b's proximity to its star and the frequent solar flares make it unlikely to support life as we know it. Others, however, suggest that life might find a way to adapt to these extreme conditions. Could there be organisms on Proxima b that have evolved to survive in such a volatile environment? Or is the planet doomed to remain a barren rock, devoid of life? As we continue to explore Proxima b with the James Webb Telescope, more secrets are sure to be uncovered. One thing is clear. This tiny planet, just 4.24 light-years away from us, is far more complex and enigmatic than we ever imagined. Could it be that Proxima b holds the key to understanding the limits of life in the universe? If so, what does that mean for our search for extraterrestrial life? One of the most shocking discoveries was the planet's atmosphere, or rather, the potential lack thereof. The intense radiation from Proxima Centauri, combined with the planet's close orbit, means that Proxima b is constantly bombarded with solar wind and high-energy particles. Over time, this relentless assault could have stripped away the planet's atmosphere, leaving it barren and exposed to the cold vacuum of space. However, some scientists believe that Proxima b might still retain a thin atmosphere, possibly composed of heavier gases like carbon dioxide or nitrogen, which could provide some protection from the star's radiation. The James Webb Telescope has given us the clearest glimpse yet of Proxima b's surface, revealing fascinating and mysterious details. The planet's surface appears rocky, much like Earth's, but with significant differences. The side facing Proxima Centauri is likely scorched by constant heat, creating a barren, desert-like landscape. Meanwhile, the dark side of the planet could be a frozen wasteland with temperatures far colder than anything experienced on Earth. Intriguingly, the narrow strip of land between these extremes, known as the Twilight Zone, might offer temperate conditions where liquid water could exist. The presence of liquid water is a key ingredient for life as we know it. Could this Twilight Zone harbor a hidden oasis where life has managed to take root despite the planet's harsh conditions? Another stunning revelation came when scientists examined the possibility of water on Proxima b. If water exists, it would likely be in the form of ice on the dark side or as small, possibly temporary, bodies of liquid water in the Twilight Zone. However, the most shocking discovery was the potential for subsurface oceans, similar to those found on moons like Europa or Enceladus in our solar system. These oceans could be heated by the planet's core or tidal forces caused by Proxima b's close orbit to its star. Such oceans would be prime locations to search for life hidden beneath the planet's icy surface. The planet's environment is further complicated by the magnetic field of Proxima Centauri. Recent studies suggest that the star's magnetic field could interact with the planet's core, generating its own magnetic field. This interaction might protect the planet's atmosphere from being completely stripped away by solar wind, much like Earth's magnetic field protects us from the sun's radiation. However, the situation on Proxima b is far from straightforward. The star's powerful flares could overwhelm the planet's magnetic defenses, leading to dramatic and sudden changes in the climate and surface conditions. These discoveries raise more questions than answers. If Proxima b does have a magnetic field, how strong is it, and how does it influence the planet's atmosphere and potential for life? Could life on Proxima b have evolved to survive the planet's harsh and fluctuating conditions? If life does exist, what form would it take? Would it be something entirely different from anything on Earth? Or could it share similarities with extremophiles that thrive in Earth's most inhospitable environments? While the idea of a habitable planet orbiting Proxima Centauri is captivating, the reality is far from hospitable. The James Webb Space Telescope has provided unprecedented insight into the challenges potential life on Proxima b would face, and the picture is anything but rosy. The planet is exposed to extreme levels of radiation from Proxima Centauri, a red dwarf star with a chaotic surface. Unlike our Sun, Proxima Centauri frequently emits powerful flares, producing a deadly cocktail of ultraviolet and X-ray radiation. This radiation would be lethal to life forms similar to those on Earth and could strip away any atmosphere that might have existed. The constant exposure to such radiation would make the surface of Proxima an incredibly hostile environment. Any water on the surface would be rapidly vaporized, and the planet's rocky landscape would be scorched by relentless heat. The dark side of the planet, while not exposed to direct radiation, would be equally inhospitable due to freezing temperatures. This extreme dichotomy between the scorching day side and the freezing night side leaves little room for a stable, life-sustaining environment. The race to reach Proxima Centauri begins. While the signal from Proxima Centauri remains a mystery, the idea of actually reaching the star system has moved from the realm of science fiction to a genuine scientific endeavor. The Breakthrough Starshot Initiative, spearheaded by a team of visionary scientists and backed by prominent figures like Stephen Hawking and Yuri Milner, aims to send tiny laser-propelled spacecraft to the Alpha Centauri system, including Proxima Centauri, within our lifetimes. The concept behind Breakthrough Starshot is as ambitious as it is revolutionary. The plan involves launching thousands of tiny spacecraft, each about the size of a postage stamp, into space. These starships would be equipped with cameras, communication equipment, and sensors to gather data as they journey to the nearest star system. What makes this mission truly groundbreaking is the propulsion system. Powerful ground-based lasers that would accelerate these miniature spacecraft to a staggering 20% of the speed of light. At this incredible speed, the starships could reach Proxima Centauri in just over 20 years, a blink of an eye in cosmic terms. Once there, they would transmit data back to Earth, giving us our first close-up look at Proxima b and the other planets in the Alpha Centauri system. The technology behind this mission is still in its early stages, but the progress made so far has been nothing short of remarkable. The challenges of the mission and the implications for the future are immense. The idea of reaching another star within our lifetimes has captivated scientists and the public alike, but it also presents significant challenges. One of the biggest hurdles is the sheer amount of energy required to propel these spacecraft to such high speeds. The lasers needed for this mission would require around 100 gigawatts of power, equivalent to the total electrical output of the United States at any given moment. This energy would have to be concentrated into a precise beam aimed at the tiny spacecraft, accelerating them over a period of minutes until they reach their target velocity. Another major challenge is the spacecraft themselves. Traveling at 20% of the speed of light means that even tiny particles in space could cause catastrophic damage to the star chips. To mitigate this risk, the spacecraft will need to be equipped with advanced shielding.